All right. Hi, guys. So here we are. This is the next video, or deeper still, it's the video that you're currently involved with. Anyway, we're going to get started with server clustering. And I think we can all agree that high server uptime is a necessity for any business that offers any kind of service, whether it's online or in the network. It's because that downtime can wreak havoc on your business, resulting in disappointing clients, revenue loss, and damaged reputation as well. So we need to avoid that, right? You might want to consider investing in server clusters to improve the uptime of your hosted web services. Okay, so now that you see where we're going, let's dig a little deeper. A server cluster is a group of several servers that work together as a single hosting solution under the same IP address, as well as the host name. So by grouping multiple servers, server clusters minimize downtime and service outages by distributing the load of tasks across the servers. When you've got this kind of architecture, you could also call it high availability cluster because it ensures high server uptime and high quality performance, regardless of the request load. What's more, server clusters support your business growth by enabling scalability for your hosted services. Now, depending on the server type, scaling can either be automatic, using cloud servers, or manual, using other types of servers. So here's how service clusters work. Each dedicated server within a server cluster is a node with its separate properties, such as a hard drive, RAM, CPU, okay? As such, each server node controls its own devices, while at the same time, maintaining a copy of the server cluster's operating system, services, and applications. So at any given time, only one node within a server cluster is operating, while others are on a standby mode, right? Now, in case an active node fails to serve a request, the server cluster redistributes the workload among the other nodes. Now, thanks to this feature, users experience no downtime while using your website or app, but your server's quite busy. The immediate switchover between server nodes is made possible by a quorum, which is a shared storage system used by all nodes in a server cluster. Now, typically, the quorum holds information on the server cluster infrastructure and tracks new changes. So, in short, all nodes within a server cluster are programmed to collaborate. As such, server clusters help to avoid downtime by balancing the workload amongst several nodes. So let's go over some of the main benefits. I'll tell you three of the main benefits of server clusters. They include increased availability, failover protection, and scalability. So we're going to dig into each of them, show you a little more detail. So high available server clusters offer increased availability for your hosted services by sending user requests to different nodes if one node's already busy. So for example, if you're hosting a web app on a single server and it's busy serving another host, well, you'll have to wait until the server's free to respond to your request. However, a server cluster has multiple nodes available at once. So if one node's busy, another node is able to serve your request. So you see how it works, right? High availability server clusters allow more people to use your website or web app at the same time. Failover protection is crucial. It maximizes your server reliability. Just like we're saying, it prevents data loss and service outage due to hardware malfunctions, software failure, or any other kind of issues like power outages caused by natural disasters. But simply put, failover clustering ensures that your services don't shut down in case your server fails. Instead, if one server node fails, another node immediately takes over the operations without causing any downtime. This feature is crucial as downtime can result in unsatisfied clients or even revenue loss, definitely things to avoid. So with cluster servers, your data is protected against three main types of outages, which include application service failures. These are all considered to be events in which critical errors occur in software or services that are fundamental to the operation of the data center or server. These issues can be caused by a number of different factors, many of which are hard to predict and prepare for. As server monitoring continues to increase in its complexity, no server admin can pinpoint and resolve these potential issues before they can actually cause an outage. A proactive and skilled server administrator can identify and address such an issue before it becomes a problem, but they still can't protect the server against this type of failure. What about hardware or system failures? This type of outage occurs because of physical hardware failures on which the server is running, right? These outages can affect every type of component that's crucial to the functionality of a server. Hardware failures can occur for a number of different reasons, but they're mostly a result of poor optimization, overheating, or some other component reaching the end of its lifespan. Now, even though no hardware component is immune to failure, here are some of the ones that are most prone to issues: CPUs, hard drives, power supplies, and the physical memory. Now, most of the time, site failures are events that occur at the data center location, such as a natural disaster, and this can cause widespread power outages like floods or fires, that kind of thing. So even though natural disasters can't be avoided by anything other than careful selection of the site location, the complications of those caused by power outages can be mitigated with server clusters. See, that's why server clusters are crucial for data centers and servers located in areas prone to natural disasters. And now we come to scalability. So whether you're hosting a web application or just a website, you might eventually outgrow your hosting solution and need more computing power. This is going to lead you to two different options: upgrading your dedicated server or using a server cluster. It's the server clusters that give you tons of room to grow by allowing you to easily scale your hosted web services. As such, using a server cluster enables you to have more content on your website, upgrade your web application with more services, and, well, you're only limited by your imagination. So let's get into the different types of server clusters. Based on how nodes are connected to the device that stores configuration data, server clusters are going to fall into one of three different types. The single quorum cluster, also called the standard quorum cluster. A single quorum cluster is the most popular server cluster type. So this type of server cluster has several nodes with one or multiple cluster storage arrays that utilize a single connection device, such as a bus. Now, all cluster disk arrays are managed and owned by a single server with the server cluster and each node notifying the central bus that it's online and uncompromised. The system that determines if each cluster is online and functional is called the titular quorum. So as long as more than 50% of the nodes in a single quorum cluster are functional and online, the cluster keeps operating. If not, the server cluster stops working until individual nodes are fixed. Majority node set cluster. So majority node set clusters are most often used for server clusters that have server nodes located in several different geographic locations. Now, this is because in this server cluster type, each node owns and manages its own copy of the cluster's configuration data. With the help of quorum resources, this data stays consistent across all nodes. Unlike in a single quorum cluster, in majority node set clusters, each node stores a copy of the quorum locally. So the server cluster type doesn't need a shared storage bus to be functional, allowing more flexibility for remote server configuration. Single node cluster. So single node clusters contain a single node, right? They're typically used for testing and developing and researching cluster applications. Single node clusters are rarely used outside of these circumstances. They're heavily limited, of course, due to the lack of failover protection, since the failover of one node disrupts the whole cluster. Now, what are we really talking about here? A cluster is a group of servers working together as a single system. This enables high server availability, load balancing, and parallel processing. What about the node? The node is an individual server in a server cluster. It operates as part of the server cluster. Nodes can either be physical or virtual instances of a server. How many servers are in a cluster? Well, a cluster can consist of at least 2 servers. This is also known as a 2-node cluster. However, you can add as many servers as you need to in a cluster. But what about the purpose of failover clustering? Well, as you might be aware, failover clustering exists to maintain the high availability of web applications and services. Failover clustering is used in case of one of the hosting servers or nodes fails, as another node in the cluster can take its workload without causing any downtime. Well, check it out. Now you know about server clustering. All right. Make of that what you will, and we'll see you in the next video.